So this is the straight line that we are getting, this straight line we are getting, okay, from this, after introducing my model, that is this one. Okay. Now I will print the value of R. So you can see this is the coefficient of correlation, negative, that is minus 0.7732138061784173. So this is the R value, that is the coefficient of correlation between the x points and y points, that is the ages of the cards and the speeds of the cards. Okay, well, now I will just I'll predict the values of a car that has the age 6 here. So I will predict the values of the speed for the car which has the age of 6 years. Okay, so let's write the codes for that. Okay, so for that we have to import rather the stats from SciPy. Okay, and I will just write these codes. So actually let's start from importing matplotlib. So now we will just predict the value of car having age 6 years, value of the speed of the car which has which is 6 years old, by implementing this linear regression algorithm, that is it will just predict. Okay, so you will get this from this best fit straight line. So let's write the codes for that. Okay, now import matplotlib add PLT. Okay, yeah, so then I will import stats from SciPy. Yeah, from SciPy import stats stats okay. So something is wrong probably here. Oh, okay. So I have here actually written 2L, so it will be single L. Sorry for that. Well, now it's okay. Yeah. Now I will just I will just put the XY data points or coordinates here, so that will be same as above. So let's just copy this. Now shift plus enter. So these are the data points that we are using. That is basically x is the ages of the cars, and y is the x is the age of the car. X coordinates actually represent the age of the cars. Sorry for that. And y coordinates represent the speed of the cars for a particular distance. So now let's introduce the slope, intercept, and r. Now let's introduce the slope, intercept, and r. For that I have to write this code: slope, comma, slope, intercept, and r, comma, p, stderr, stand, equals stats dot line regression, that is line regress. It will be actually the code, so that is this line regress, linear regression. Actually this is line regress. Well, so here it is. Sorry for that. Double R is okay. So this is stats line regress. Yeah. Well, that's xy. That's xy. Okay. Now here, oh, okay. Sorry. Here it will be underscore. Sorry. Oops. Well, now I'll have to introduce the function that is here. Sorry, my function x my function x return return so I have to just introduce the relationship between the slope, so it will be x plus x plus intercept, right? Yeah, so it is intercept well, that's nice. So it is I've already introduced the function. Now let's I have to calculate the speed for a car. My prediction, the machine will predict actually. So I'll just predict I want to know the speed of the car that has age 6. Okay, so for that I have to just write the function here. This function. Let's just implement. Let's just write this one. I think this will work actually. Speed equals my function of 6 rather. Okay, so that's fine. Now I will print the value of speed. Print speed. Okay. So you can see this is the speed of the car with age 6 years. This is the speed 86.7536. This one you can see the output 86.753646246247697996. So basically 86.75 or 76. This is the speed. So you can see from this from this best fitted line as well. You see this is the 6. If you see, if you draw the straight line from this point, this is the 6. Sorry, yeah, this is 6, right? And its y coordinate will be like this. Its y coordinate will be like this, somewhat here. You see, then we draw the straight line. and enter here. So this point, so it should be 86 around speed. Okay, so that's the idea. So in this case, you can, in this way, you can predict the, you can use the linear regression machine learning algorithm, and you can predict the linear regression. You can predict the, you can predict whatever you want from, and you can get the information. You can get the output from this best fitted straight line. So that's it. That's the this is how you can write the codes of the linear regression algorithm. You can see, and we can do it very well, because very easily you can see this is. So for that, what you have to do, you have to just launch the Jupyter notebook and have to write this. You have to import the libraries. That is, here I have imported matplotlib.pyplot as PLT. Then I have just mentioned the XY coordinate that I've chosen the XY coordinates. So whatever data you have, you can put it here as well. And then I plot the scatter plot of these XY coordinates. So this is the scatter plot, the normal plot of the two-dimensional plot in the XY plane. And you can see then plt.so. So then I have done, what I've done is I've just introduced the R, slope and intercept, so that I can get the best fitted line, straight line, and that is and from the best fitted straight line of all the data points that you can see here. So I have for that I have mentioned these things. I have introduced rather slope, intercepts, the best fitted straight line, and R as well. What is R? R is basically the coefficient of correlation between the x coordinate and y coordinates, or the variables rather, more precisely. So here I have just mentioned, I have introduced the x coordinates as I've introduced the speeds of the cars as the y coordinates, and the x coordinates represent here the x coordinates represent the ages of the cars, right? Okay, now here I have just mapped the data. I have just introduced the function, so that y it looks like it's like y equals mx plus c, where m is the function, slope, and c is the intercept. So, and y is the function of x, the another variable. So y is the function dependent variable, x is the independent variable. So dependent, this is the straight line equation of the straight line for this best fitted straight line that we want to get, and we are having this type of equation. So I have introduced that function, and later on, we have already got the straight line, best fitted straight line in this linear regression algorithm. See, and before that I had mapped here as well, the mapping from my function, that is the y in the, what you can call the y of my function, and to x, that this x, so this is a scatter plot, and then that's my model, that is I am just mapping the function here to x, mapping between y and x, or my function and x. So now we have got the linear regression best fitted plot, straight line for all the data points out there. Then we have got the R as well, the coefficient of the correlation between all those 2 points, 2 variables, all the 2 variables, those 2 variables, that is x and y here. That is when the variables are here, that I have assumed here the other 2 plots, like you can see those plots. So the variables here are the ages of the cars and speeds of the cars for a particular distance. Okay, so and if there is no correlation coefficient between the variables, then there is no existence of this the entire thing will be meaningful, will be completely meaningless. So since obviously, so we have got the R value, that is the coefficient of correlation between these 2 variables, x and y, or the age of the cars and speed of the cars, and this reads like these: minus 0.7732138061784113. So that is the idea. So then the next part is, so after getting the best fitted straight line by the linear regression algorithm, the next part is to predict to predict the y value or the anything or the speed of the car that I have already mentioned for a random car with having 6 age or any age value of the car or whatever. So basically the basic thing is basically you have to set a value of the independent variable to get the value of the dependent variable, that is the y here, y equals mx plus c, and from the straight line, base period straight line, you can get the point or the speed of the particular car having that particular age. So that's what I've done. I've set the car's age at 6. So then I'll just define his speed as here, define speed here. So the car's age is 6. I've said here you can see 6 age, and then it's corresponding from the plot itself. You can also get, if you do the straight line here to here, it will be around 86. So from plot you can see the speed of the 6 years old car will be like this from the plot. And you can also by writing code you can also see that that's what we are getting as well. So this is 86, around 86.75. you can get it from the plot itself. So that value is being predicted by the linear regression algorithm, and that's the thing. And you can calculate the error you are getting from the data points and the mean as well. This is how you can write the linear codes for linear regression algorithm, a machine learning algorithm rather. So that's it. Okay. Now we will talk about the how to write codes for decision tree algorithm. Okay, this is a machine learning algorithm. Yeah.